Welcome to day one of our 30-day AI mastery journey. Today we begin at the very foundation. We start by understanding what artificial intelligence truly is, what large language models are, how they work, and why they have become such a transformative technology. Our goal today is to make the basics strong, to give ourselves a clear mental model of AI, so that in the coming days we can use tools, build projects, and eventually monetize our skills with confidence. Artificial intelligence, or AI, is the science of creating machines that can perform tasks that normally require human intelligence. This includes reasoning, learning, problem-solving, perception, understanding language, and generating creative outputs. When we think of intelligence in humans, it is our ability to analyze information, recognize patterns, make decisions, and communicate ideas. AI attempts to replicate some of these abilities in software systems. It is not magic, it is computation, mathematics, and data working together to produce intelligent behavior. There are many types of AI, but one of the most important distinctions is between narrow AI and general AI. Narrow AI is designed to perform specific tasks. For example, a chess engine can play chess extremely well, but it cannot drive a car or write poetry. Similarly, a recommendation engine can suggest videos or products based on your past behavior, but it cannot explain a complex scientific concept. Today, almost all AI systems we encounter are narrow AI. They excel in specific domains but do not possess general intelligence. On the other hand, general AI, or AGI, is a theoretical form of AI that can perform any intellectual task a human can do. We do not have true AGI yet, but the advances in large language models and other AI architectures are slowly bridging the gap by giving machines more flexible, generalized capabilities. One of the most powerful developments in AI in recent years is the rise of large language models, or LLMs. LLMs are AI systems trained on massive amounts of text data to understand and generate human language. They learn patterns in words, sentences, and paragraphs so that they can predict the next word in a sequence, answer questions, summarize content, translate languages, or even write code. Some of the most famous LLMs include OpenAI's GPT series, Google's Bard, and Anthropic's Claude. To understand LLMs at a deeper level, we need to consider their architecture. LLMs are built using a type of neural network called a transformer. Transformers have revolutionized AI because they can process and understand sequences of data, such as text, more effectively than previous models. At a high level, a transformer takes input text, converts it into numerical representations called embeddings, processes them through multiple layers of attention and feed-forward networks, and outputs predictions for the next word or sequence. The attention mechanism is what allows transformers to weigh the importance of each word relative to others, which is why they can generate coherent and contextually relevant responses. Training an LLM involves exposing it to vast amounts of text data, sometimes hundreds of billions of words. The model learns statistical patterns in the data, which allows it to generate text that resembles human writing. Importantly, LLMs do not understand language in the same way humans do. They do not have consciousness or intent, but they can emulate understanding by capturing the patterns and structures inherent in human communication. A critical concept in LLMs is tokens. Text is broken down into tokens, which can be words, subwords, or even individual characters. The model predicts the next token based on the sequence of previous tokens. This token-based prediction is what allows LLMs to generate text that flows naturally and responds appropriately to prompts. By learning the probabilities of sequences of tokens from its training data, the LLM can perform tasks ranging from summarizing an article to generating computer code. Another important concept is fine-tuning and reinforcement learning. While the base LLM is trained on a massive general dataset, fine-tuning allows the model to specialize in certain tasks. For example, a model can be fine-tuned to answer medical questions, write legal documents, or generate poetry. Reinforcement learning with human feedback, or RLHF, is a process where human evaluators provide feedback on model outputs, which helps the AI align with human preferences and produce more useful or safe responses. It is also essential to understand limitations of LLMs. Even the most advanced models can hallucinate information, meaning they may generate plausible but incorrect or nonsensical responses. They are sensitive to prompt wording, and small changes in instructions can produce drastically different outputs. LLMs do not have memory in the same way humans do, although recent architectures introduce mechanisms for longer context handling, allowing models to remember parts of a conversation or document across thousands of words. Understanding these strengths and limitations is key before we begin using AI tools. Another foundational concept is emergent capabilities. As LLMs grow larger and are trained on more data, they exhibit behaviors that were not explicitly programmed. For example, very large models can perform basic reasoning, arithmetic, summarization, and even translation without being specifically trained for these tasks. These emergent capabilities are what make LLMs so powerful and flexible, and they hint at the potential of future AI systems. Finally, we need to understand AI ethics and safety. LLMs and AI tools can produce biased or harmful outputs if not used responsibly. Being an effective AI practitioner involves understanding bias in data, ensuring fairness in outputs, and using AI in ways that are safe, ethical, and aligned with human values. Even at this early stage, it is important that we develop habits of critical thinking, verification, and ethical reflection when interacting with AI. By the end of today, our goal is not to generate images or text with a tool but to internalize these core concepts. We need a mental model of how AI works, how LLMs generate language, what their strengths and limitations are, and why prompt clarity is crucial. This foundation will allow us to move confidently into practical AI applications starting tomorrow. Today we take notes, visualize the architecture of an LLM in our minds, and discuss examples. For instance, when we ask an LLM to summarize a book, we now understand that it is not reading the book. It is predicting the most probable sequence of tokens that would represent a summary based on patterns it has seen during training. When we ask it to answer a question, it uses the statistical correlations it has learned, not personal knowledge or consciousness. By thinking like this, we demystify AI and prepare ourselves to use it effectively and responsibly. Day 1 is complete. We now have a strong conceptual foundation in AI, understand LLMs, tokens, transformers, emergent capabilities, fine-tuning, and ethical considerations. Tomorrow, we will begin exploring prompt engineering, learning how to communicate effectively with AI to generate useful outputs and start practicing small real-world AI workflows. By building a strong mental model today, we ensure that our journey over the next 30 days is grounded, structured, and powerful.